Hello, everybody. In this video, we're going to have some Excel exercises applying matrices, probabilities, and propositional logic, as well as number systems. So we're going to start with problem 1. Here we have a company which has 2 departments. And each department, there are 3 sections. So A, B, C here actually belong to the first department, 3 sections. And DEF belong to the second department. So all in all, we have 6 sections, 3 sections in department 1 and 3 sections in department 2. So AC here is our accountant and PC property consultant or consultants, okay? R receptionist, OM operations managers, and CL equals clerks. Okay, so we can save space. So these variables are given in columns already. So these are the positions or the post in this organization or company. So in every section, each section, there are 3 accountants. So this will be 3. So since all are 3, just select 3 and drag it down. So this is the meaning of that. Every section, there are 3 accountants and 5 property consultants. So 5, select the number and drag it down, save time. So you don't need to write it manually. And R here is receptionist. We have only 1. So 1 and select the cell, drag it down. Okay? So that's the meaning of that. Each section, 3 accountants, 5 property consultants, and 1 receptionist. And 1 section of a department. What's the meaning of this? Only 1 section in 1 department. But we don't know which department. So somehow we can choose any department and any section. So we can choose department 1, section A. So there we're going to write 2 and the remaining 0. So select 0 and drag it down. So here, as you can see, we have only 1 section and 1 department. Basically, you can put 2 anywhere. Yeah, because it's not mentioned actually which department and which section. So it depends on your choice where you're going to put 2. So anyway, you select the first section and first department, that is A. Put 2 there. A, and the last in each section of other department. So this is our first department. We have 3 sections. These are the sections of the other department, DAF, where 2 clerks are also working. So here we have 2, 2, and 2. And this will be 0, 0, 0. Okay. So this is actually about matrix addition. Okay. And this table actually is a matrix. A matrix is nothing but a table. Actually, it has rows and columns. So we are going to find how many are in department 1 and department 2 and both departments. That's the question here. Okay, so for department 1 equals sum. Double click the sum below and select the values opposite ABC, only the first column. Okay, and hit enter like so, and select the answer 9 and drag it to the right. As you can see here, we have the sum of this 3 is the sum of this, and so on. And for department 2, that's equals sum of the first column opposite D, E, and F. And hit enter. So select the answer 9 and drag it to the right. Okay, so these are the sums for department 1, and these are the sums for department 2. For accountants, property consultants, receptionists, operation managers, and clerks. Now for both departments, we're going to add department 1 and department 2. So this is equals, select the value of department 1 and plus department 2 and enter. So that is 9 plus 9, 18. And select 18, drag it to the right. Okay, so all in all, if we're going to select, there are 62 employees. So 18 accountants, 30 property consultants, 6 receptionists, 2 operations managers, and 6 clerks. So these are all the people working in this organization or company. Now, here, the second one is about probability. So out of 100 students, 13 failed the entrance test. What is the probability that all 5 students failed if the first, second, third, and fourth students are selected randomly from the group without replacement? So these are the keywords: without replacement. So this is a scenario involving dependent events. Okay, because the first event depends or is affecting the other events. Okay, the second is affected by the first, the third is affected by the second, and so on and so forth. Why? Because we are not replacing. So we select one and remove. So for example, during the first pick, still it is 100. Okay, the second pick, it will become 99. Okay, for the first pick, the total is still 100. For the second pick, it's going to be 99. Okay, it keeps on decreasing because actually we are not replacing every time we select. So the first one, the question is about failed, okay? That all 5 students failed. Now, it is given that there are 13 students who failed the entrance test. So the first one will be 13 over 100. So 0.13, and you can increase from here. Okay, so 0, 0, it means this is only exactly 0.13 because 13 over 100. For the second pick, it will become 12 over 99, assuming that the first student picked was the student who failed. Okay, was a student who failed. So 12 over 99. So we can increase, going to be like that. And here for the third, it's going to be 11 over 98. First one is 100. Second one is 99. And here we have 98. So that's the value. So the first one is 13 over 100. Then 12 over 99. 11 over 98. Then here equals 10 over 97. That's the fourth. And the fifth will be affected because first, second, third, and fourth are not replaced, okay? So this will be, this is 13, 12, 11, 10. So this is 9. This is 100, 99, 98, 97, 96. Okay, so these are the values. Again, the first one, 13 over 100. Second one, 12 over 99. 11 over 98. 10 over 97. 9 over 96. Now, all here means, all of them. So the students that we selected should be all failed students. So what is the probability? Not only one, not only two, not only three, not only four. It should be 5 students, all 5 students. So all, both, and actually we multiply. Okay, so first times the second, multiply by the third, times the fourth, multiply by the fifth. And enter. Okay, so actually it's very small. 1.7 something times 10 raised to the power of -5. So we have to move 5 places to the left. Okay, so equals, select this value to get the percentage. Okay, if this is a number, for example, okay, click percent and increase. So this is the value in percentage. So actually you can convert this directly to percent, but I want to see the decimal and I want to see the percentage. Okay, so for that we have to press equal sign and select the value. So basically what we're doing is just copying the value, whatever is the value here, but since it is already in percent, it is converting automatically. Okay, so here we have 0.00. You can increase and click percent. It will give you some more digits to the right. So it's very small. It's close to 0 because all 5 students should be those students who failed, and only 13 over 100. Okay, so that's it. Let's proceed to the second one here. The third one. Okay, we are done with the first and the second. The third one is actually converting our number systems to different number systems. Now, it depends on the given actually. It's up to you which one you're going to use. So here, there are 2 given, octal and decimal. You can use the decimal or octal to convert to binary. So equals, if you want to use octal, so OCT to bin, the first one. Okay, because we are converting to binary, select 56 or you can write 56 and hit enter. So this is the binary number. For hexadecimal, you can use the binary number, you can use the octal or decimal. So assuming you're going to use decimal, so DEC to hex, the second one, and decimal is 46 and enter. So the answer is 2E. Well, it's up to you. You can use the binary as well. Bin to hex, okay? And select the binary. Still is going to give you 2E. So it's up to you which one you're going to use. Here we have the binary and hexadecimal, and we're going to convert to octal or decimal. We can use the binary. So equals bin to octal because we're changing to octal, and select the binary, enter 157. Here you can use binary or octal. So assuming you're going to use the binary, to decimal, okay? Because we are converting to decimal. Select the binary. The answer is 111. Of course, you can use the octal as well, equals octal to decimal. Select the octal number. It's going to give you the same answer. Here equals bin to octal, because we have the binary here. Select the binary, gives you 137. So it's very easy actually to convert any number system using a software, especially MS Excel. Okay, so let's have the fourth. Please try to rewind the video. Okay, pause the video, forward. Okay, and try to do it on your own. Try to practice until you get all the answers accurately. Okay, so here we are asked to create a system using matrices. Okay, create a system and matrices and solve the problem. So that means this is solving a word problem involving or using matrix inverse. Of course, the first step is to understand the problem. Okay, so this is an institute offering 2 courses. The first course is X. Okay, so we can define our variable immediately here. X is equal to first course and Y equals the second course. It's given here. Right? So that's the variable. These are the variables. Now the system, we have $850 for the first course. So it's 850 X plus the second course cost $999. So 999 Y equals the total amount. The total amount is 1766.98 as mentioned here. Okay, now the institute actually had a total of 190 participants. So it means that X plus Y equals 190. Okay, so let's now create our matrices. Matrix A, these are the numbers before the letters. So 850X, first value is 850, and the second value is 999. And here we have X plus Y equals 190. So that's 1X plus 1Y, so 1. Our B actually is a matrix containing the values after the equal signs. Okay, so the first one is 1766.98, and the second one is 190. All right. So the next is to find the inverse of A. So what we're going to do is to select 4 cells because we have 4 elements above the elements of A. So we select 4 cells and hit equal sign MIN and find the M inverse, the last one. Double click, select the elements of A, then Control Shift Enter. So these are the elements of our A inverse. Then now we can find our X and Y. We select 2 cells opposite this X and Y. and equals MM, matrix multiplication. We select the inverse, comma, we select the elements of B, and Control Shift Enter. Okay, so that's how to solve these problems. We're going to continue with other problems in the next video. Thank you so much for watching. Until the next time, bye-bye.